So lesson 11.2 combinations, we're going to start with a recap from 11.1. So they're saying how many arrangements of all the letters of the word reason are there if the arrangement must start with an S. So what I like to do is I like to have 6 spots to represent each letter of the word. We know that an S has to be first, and you always want to see if there's any repeating letters, because then you would have to divide out repetition, but there are not. And then we have 5 letters left, so that's going to be 5, 4, 3, 2, 1. So one way to write this would be 5 factorial, but that's also equal to 5p5 times 1. So that would be a way of writing this, and all of these would give you the answer of 120 different arrangements. Question 2, if all the letters of the word diploma are used, and how many different arrangements are possible that begin and end with an I, O, or A? So we want it to begin and end with those letters. So we have 7 spots. So we have 3 choices for the first spot because there's 3 letters here. And once we use maybe an I for the first spot, there's only 2 letters left for the last spot. And then since we already placed 2 items in the first and the last spot, we have still 5 letters left. So that's going to be 5, 4, 3, 2, 1 multiplied. So we can write 6, which is the same thing as 3 times 2 multiplied by 5 factorial. And that's actually equal to 6 factorial, which is 720 arrangements. So this new lesson is about using something called combination. This is where order does not matter. So there's 2 ways to write it. We use this NCR, or we can have something like 5 choose 3 is equal to 5, 3. So this is the way that we calculate it, 5 choose 3, but we can write it as 5, 3 with these rounded brackets around it. No kind of division symbol, nothing like that. It's just a way of writing it. Example number 1, in how many ways can a debating club coach select a team from 6 grade 11 students and 7 grade 12 students if the team has 4 members? So as you can see, this is not trying to place them into certain spots. That's why order does not matter here. So for this one, I have 11, it says 6 grade 11 students and 7. So together I have 13 people. So I have 13 people to choose from, and I have to make a 4-member team. And what we're doing is we're assuming that they're all doing the same job, which is why order does not matter. And we can put this into our calculator by going to our graphing calculator, clearing whatever we have there, putting 13 math probability number 3, and then we're going 13 choose and then 4 equals 715 as my answer. So make sure you're using the right number and the right calculator buttons. For B, it says 4 members, only one of whom is in grade 11. So in this case, they want 1 grade 11 students. So that means from 6 grade 11 students, I'm only choosing 1. And then we're going to multiply because this means and. So and the other 3 members of the team, meaning the other 3 spots of the team, have to come from the grade 12 students. So there's 7 of those to choose from. So that's going to be equal to 6. 6 choose 1 is equal to 6 multiplied by 7 choose 3 is equal to 35. And so our answer is 210 when you multiply these 2 numbers together. Again, we're using our calculator to calculate that. We're going 7 math probability number 3, and then 7 choose 3 is equal to 35. So that's how I got those answers. Example number 2, Rihanna's writing a geography exam. The instructor says that she must answer a specified number of questions from each section. How many different selections of questions are possible if she must answer 2 of the 4 questions in part A and 3 of the 5 questions in part B? Okay, so for A, all we have to say is we're answering from 4, we're choosing 2. And then for part B, from 5, we're choosing 3. If you put those into your calculator, you should get 60 as the answer. Now B, it says she must answer 2 of the 4 questions in part A and at least 4 of the 6 questions in part B. So this is where we're going to have cases. Case 1 could be where we answer at least 4 of the 5 questions. So this is where we can answer 4 questions in part B. And then case 2 would be, what if we answer 5 questions in part B? So we still start with the same part for part A. Part A will still be answering only 2 of the 4. So from 4, we're choosing 2. Same thing for case 2. But when we're choosing 4 questions to solve, we're saying that there are 5 to choose from, and we're only choosing to answer 4 for case 1. And from 5 questions, we're answering all 5. So we're going to get each of these answers separately. So for case 1, when you multiply 4 choose 2 times 5 choose 4, you should get 30. And multiplying 4 choose 2 times 5 choose 5 should be equal to 6. And then what we do between the cases is we always add them together to get our final answer, which in this case is 36. Example number 3, it says a bag contains 7 black balls and 6 red balls. In how many ways can you draw groups of 5 balls if at least 3 must be red? So this is where, again, we have to do cases. So case 1, we could have 3 red. Case 2, we can have 4 red. And case 3, we can have 5 red. And the reason we stop at 5 red is because we can only have 5 balls total. So that means we have to stop before we go over that limit. So in order to choose 3 red balls, there's 6 to choose from, and we're choosing 3. Then from 6, we're choosing 4, and then from 5, we're choosing, from 6, we're choosing 5. Now this one's already done for you. So this last one, you're already done because we have all 5 balls. So this is 5 balls. But in case 2 and case 1, we don't have the 5 necessary balls. We have to finish this question. So in case 1, we still need 2 balls from the 7 black. So from 7 black, we're choosing 2 more to make 5 total. And that's going to give us 420 choices. And then from case 2, where we already have 4 balls, we still need 1 more from the black one to make, as you can see, these numbers have to add up to 5. The previous ones add up to 5, and the last one adds up to 5 for your R's. So that's going to, when you multiply those two answers, it gives you 105, and the last one gives you 6. So always add between the cases, and you should get 531 different ways that can happen. Example number 4, how many ways can one or more of 5 different toys be selected? So we could have selected 1 toy. So from 5 toys, we'll select 1. Or from 5 toys, we'll select 2. From 5 toys, we'll select 3. And from 5 toys, we'll select 4. And then from 5 toys, we can select all of them. So once we add up all these answers, you should get 31. So in all these cases, you should be noticing that order doesn't matter because they're just asking us to select a certain number of toys. They're not asking us to line them up or to arrange them in a picture or to rearrange them where it looks different. So order does not matter, which is why we're using this NCR. Example number 5, it says, a math class has 18 male students and 19 female students. A committee of 7 is to be selected. Now we're assuming that they're all doing the same job, which is why we're using this combinations idea. So we need to have at least 1 female on the committee. So this is again where we can do cases. We can have one female, we can have two females, we can have 3, 4, 5, 6, 7. So that's a lot of cases. So there is a faster way, and it's by doing the complement, by doing the opposite way of thinking. So we can look at least one. The opposite of that would be where there's no female. So the complement of having one female, at least one female, would be having no females on the committee. So what we can do is we can subtract this complement number from the total. So if we take total minus no females, every committee from this, when I subtract them, will have a female on it. So a total would look like this. There's 37 total people, meaning 18 males plus 19 females equals 37. So there's 19 people to choose from, and we have to make a committee of 7. That's our total. No females would mean that they're all male. So that means from 18 males, we're choosing 7 of them to be on the committee, meaning all of them are male. If you take these two answers and subtract them, you're going to get this, which is all the committees where there is at least one female. So that's just a faster way instead of doing 7 cases, which would be a lot. Example number 6, it says a committee of 6 to be chosen from 3 girls and 7 boys. 2 particular boys must be on the committee. Find the number of ways of selecting the committee. So let's start by selecting the 2 particular boys that have to be on there. So there's 2 boys and they're on the committee, so I've selected them. Now there's still, we know that there is supposed to be 3 girls and 7 boys. Now that means that there's a total of 10 people, and we have already used 2 people, which are the boys, on the committee, so we're subtracting the 2 people we already used. There's 8 people left. So from the remaining 8 people, we have to choose 4 more members to be on this committee, because we need to make sure our R values add up to 6, because it needs a committee of 6. If you multiply these answers together, you should get 70 in your calculator. Example number 7, how many 5-card hands can be dealt from a standard deck of 52 cards? Well, each hand must contain 2 aces. So we have to ask ourselves how many aces are in the deck. There are 4 to choose from, and they want us to have 2 of them. But we need to have 5 cards in our hand, so we've only have 2 right now. So that means we still need 3 cards from the non-aces. So 52 cards, if we subtract the 4 aces, there are 48 cards left, and we have to choose 3 more to make our 5-card hand. So if you put that in your calculator, you should get 103,776. For B, we have to have 3 red cards. So there's 26 red cards in the deck, and we want 3 of them. That means from the black cards, there's 26 as well, and we need 2 more that are black. So these are red, these ones are black, and now if we put that in our calculator, we get 845,000 ways that can happen. Example number 8, it says, what if there are 8 points on a coordinate plane? No 3 points are collinear. So they're saying how many ways can we connect these 8 points to make a line segment? Well, we have 8 points and we need 2 points to make a line segment. So anytime you connect on, let's say you have points here and you connect them, that makes a line segment. So 8 choose 2 will give us our answer of 28 line segments. And the same idea for triangles. If I had 3 points, I would be able to create a triangle. So from 8 points, you're choosing 3 to make your triangle, which can create 56 triangles. And for C, a quadrilateral. That just means from the 8 points, you're choosing 4, and that's going to give us 70. Now for this next one, there's actually an equation that we're going to use. In order to make diagonals, you have to take how many points there are, choose 2, and subtract your sides again. So the n represents your points, or in this case, your line segments, your side lengths. So n represents how many sides there are on your shape. So if we're talking about a hexagon, we actually have 6 sides on a hexagon. So we're choosing 2, subtract 6, and if you put that in your calculator, you should get 9. So that's for a hexagon. For an octagon, we have 8 sides, so we're going 8 choose 2 minus how many sides we have, and that's going to give us 20. So this is the formula that we use if we're trying to find out how many diagonals can be created. Example number 10 is using our formula sheet. So we have a formula that looks like this. NCR is actually equal to n factorial over n minus r factorial r factorial. So for A, we're going to express it as factorial notation and simplified. So the top is going to be n minus 1 factorial over, we always go n minus r, which is n minus 1 minus 3 factorial, and then r factorial, which is 3 factorial. That's going to multiply by 1 over, so I'll actually write it as like 1 dividing by n minus 2 factorial over n minus 2 minus 3 factorial, 3 factorial. So I'm just replacing this and this using the equation that I have written there. So that's from your formula sheet. So I'm going to simplify this as much as I can before I continue. So n minus 1 minus 3, I just simplified it as n minus 4. And then 3 factorial can be evaluated, and that's equal to 6. Multiplied by 1, multiplied by the reciprocal. So these guys are going to flip. So it's going to be at the top n minus 5 factorial, 3 factorial is 6, over n minus 2 factorial. So the 1 I can cross off, that can go away, and the 6's can actually cross off because there's 1 in the numerator, 1 in the denominator, so they can cancel each other off. So this is what you're left with so far. And then what I do is I always start with that, I try to start with the bigger one and expand it. So for example, n minus 1, if I were to continue n minus 1, after that would be n minus 2. So if I stop there, I can actually cross things off. So you'll notice that these two cross each other off, leaving us with n minus 5 and n minus 4 still that we can still simplify. So n minus 4, we can rewrite it as the top stays the same, but the bottom I can write it as n minus 4, and what comes after n minus 4 is n minus 5. That can help me cross that top one off. So these guys will cross each other off, leaving us with n minus 1 factorial over, actually the factorials crossed off at the top, so I shouldn't have these factorials here. So all you're left with is then n minus 1 over n minus 4 as your final answer. Now B, it says we want to solve for n. So this one's a little bit more complicated. We want to write 720 multiplied by n factorial over n minus 5 factorial, 5 factorial. And that's equal to, this one is using the NPR formula where it's n plus 1 factorial over n plus 1 minus 5 factorial. So we have 720 n factorial over 5 factorial is like 120, so I'll write it as 120 instead in front. N minus 5 factorial, leave as it is. The right side will be n plus 1 factorial over n minus 4 factorial. So what I'll do is 720 divided by 120 is actually equal to 6. So I'll have 6n squared over n minus 5 factorial. And then with the n minus 1, what comes after n plus 1 is just n factorial. So I'll stop there because then you'll notice that there's the exact same factors on the left and right side in the numerator, so those can actually cross each other off. And at the bottom, we have n minus 4 factorial. So now on the left, we have 6 over n minus 5 factorial. And on the right, we have n plus 1, just n plus 1 in brackets, over n minus 4. And what comes after n minus 4 is n minus 5 factorial. Just like in the previous case or the previous step, whenever you have the exact same things on the same level across an equal sign, they cancel each other off. So now I'm going to cross multiply. 6 is going to multiply with n minus 4, and on the right side I'm going to have n plus 1. The 6 is going to distribute into the brackets. 6n minus 24 is equal to n plus 1. Now we're going to solve for n by bringing the n's to one side and the numbers to the other side. So it's going to be 5n equals 25, which means that n is equal to 5 as your final answer. If there is, for example number 12, problem solving, if there's 190 handshakes in a room and everybody shakes every person's hand one time, how many people are there? Well, n represents how many people there are. Choose. There are 2 hands or 2 people that are needed to create one handshake. So n represents the people and 2 represents how many people you need to create one handshake. So we're trying to evaluate this. So what we could do is replace our NC2 with the formula n factorial over n minus 2 factorial, 2 factorial. So the 2 factorial can multiply to the other side, so that's going to be multiplied by 2 factorial, so we're just multiplying it to the left side. And then the n can expand and keep going until we get to the bottom factor, which is n minus 2 factorial. So these guys cross each other off, and then 190 times 2 is 380. And we're going to distribute that n into the brackets. And now we have a quadratic equation if we move everything to one side. So these actually nicely factor as well. 2 numbers that multiply to negative 380 and add up to negative 1 will be n minus 20, n plus 19. N could equal either 20 or n could equal negative 19. Well, we can't have negative 19 people in a room, so the only answer that makes sense would be 20 people in the room. Okay, so that is a lesson 11.